Hey, happy Halloween. All right, here we go. Sorry about this thing. Here we go. This is the next section that you're going to be working on. It's called graphing linear equations. It's another step into the real world of algebra, into what we're really going to be doing from this time forth. And so here it is. This says a solution of an equation in two variables, x and y. Oh my gosh, we have more than one letter going on at one time. Is an ordered pair. We talked about ordered pairs last time. That's the things in the parentheses, the x and the y, right? So that's a solution. We show it in those ordered pairs, all right? And those solutions are right there. In this lesson, you're going to see that those solutions lie on a straight line, and I'm about to show you a straight line. Here it is. Blobbity, blobbity, blobbity. Oh, there it is. All right. This is an equation, all right? But it has two variables, and you probably can't see it, so I'm going to write it again or make it a little bit darker. This says x plus 3y equals 6. Now this is what they call the standard form of an equation of ax plus by equals c. And you'll hear all sorts of different types of forms of an equation. And all you really need to do is plug in a couple of coordinates to see if they work out, right? And then you're just going to do the math and see if one side is the same as the other. That's why there's an equal sign there. You got to see if one side equals the other. And you got to look, for me personally, to see if it lies on that graph. And I'm going to cheat first, okay? You see this line? If they give you the line of that graph, and they give you coordinate pairs, and they give you the equation, and you want to just look ahead and not solve right away, just see if it's going to be there. You can check your work. You can say, oh, I have a coordinate pair. My x is 1 and my y is 2. So I'm going to count over 1 and up 2 and see if it lies on the graph. Now, I'm not so sure that this is actually the graph of the equation that we see, but let's find out. I think it is. If I count over 1 and up 2, is this dot lying on that line? You're going to say, no, sir, the dot isn't anywhere near the line. It's above the line. Okay, well now we know that when we do the math here, we're not going to get out the right number. But let's go ahead and do what the teacher tells you to do, because teachers are always right, because we're perfect. We're going to put in a 1 for x. We're going to put in a 2 for y. We're going to do some math, and then we're going to see if what's on this side ends up being exactly what's on this side. That's what it says. It says put the points in. So here I go. I have an x, and I'm going to make it 1. Plus 3 times whatever y value I have, that's a 2, equals 6. All right, you already know, because you're smart, because you've already done 3 times 2 is 6 plus 1 is 7. Hey, wait a minute. 7? That's not equal to 6. Wrong. Not a solution to this particular equation. All right? Okay, that's fine. This wasn't a solution. Let's try the next set. See if that one works out. We'll leave that alone. Now we're going to look at our x and y of -3. Oh, negatives. Oh my gosh. Whatever. -3 for our x, and +3, 3 times +3 for our y. Okay, let's cheat. Don't tell anyone we're going to cheat, but we're going to do the cheat. Count backwards. 1, 2, 3. That's -3 on the x-axis, right? That's what it says. On the x-axis, go back 3 spaces, and it says go up 3 spaces. 1, 2, 3. Is that dot on the line? You bet that dot's on the line. We know it's going to work. So let's do the math. Negative 3, it's always going to be negative 3. 3 times 3 is 9 equals 6. Wait a minute, positive 9 and negative 3, that's 6. Hey, see, we saw it graphically, and we saw it by doing the math, by plugging and chugging the way we're supposed to do. All right, so that's how, if you're given an equation and a couple of coordinate pairs, now you can find your solution. I'm going to move on to the next page, and we're going to talk about that. So give me a chance to slide this down to the next page. There's example 2, a different equation. And of course I got to get rid of that line. So now, oh, nuts and bolts, where'd I go? Oh, I ruined everything. Sorry, dude. I'm getting there. There it is. Okay, so my computer's a little fuzzy. Doesn't think right. There it is. I want to show you that this is the graph of the equation. This right here, this is the graph of that equation. I want to see what form they write it in. Okay. Y plus 2 equals 3x. Oh, we like that. Okay, well, it doesn't say anything about what you're supposed to do here, so I'm going to tell you what you're supposed to do here. They have cheated in this book, okay? In your textbook, they have cheated. They have decided to make it y equals something, right? And that's a really great way to do it. If you put something into y equals something times x plus or minus something, that's in slope-intercept form. That's coming up in like 3 or 4 lessons. I don't remember. It's coming up. Don't worry about it yet. But get used to seeing this form. It's going to be one of your best friends in algebra. A lot of stuff can jump right back to that. So don't ever lose it. All right? So here's our equation. Here's a table we've made so we can find out what we get when we input and get an output. Input, output, input, output, input, output. You should have done this last chapter with inputs and outputs because you were talking about functions, right? You made your function machine or you just did your input-output tables and you looked at what happens if you have a certain x variable or your wonderful input variable, and then you did some math with it and showed what you got out of it, which is going to be your y. Here we go. This is the graph of that equation. I wonder if I can blow it up just a little bit and color it in. Yeah, that should be good. That should be good. I'm going to write the equation over the top of it so we can really see this sucker. Pardon my language. Too big. Sorry about that, kid. Ruined everything. Ah, it's so much better. There we go. That's perfect, right where it is. Now, we say that this equation is y equals 3x, and I think it's minus 2. All right? There's our equation. Here's our input-output table. It says if we input for x -2, we do all that math and we get -8 out. They've done all the work for us. And then we put it down here, -2. Go back 2 spaces. Go way down here on the graph, and it's got a dot right there at -8, right at the bottom. And if we follow suit and we look at all these, we see it's got, oh yeah, these are all the dots. These are all the things that they've created here. And we have, if we connected the dots, we have a straight line. So when you have equations, you can also create an input-output table, and do the math. So they're telling you, go ahead, input a 2 for x, and then do the math and find out what comes out. So if you put in a -1 per se, you'll put in a -1 for x, you'll multiply by 3, that's -3, minus 2, which is -5. All right? If you put in a 0 for x, 3 times 0 is 0, minus 2 is -2. There it is, right there. Etc., etc. Put in a 1, put in a 2. These are your inputs and your outputs. Now, you don't always have to put all the math in here. If you're smart and you know all that math, you can go ahead and create the table that looks nice and clean, like this. Make an XY table with this over the top of it, and we'll see -2 gives me -8, -1 gives me -5, 0 gives me -2, 1 gives me 1, and 2 gives me 4. And that's okay, that input-output table, just like that. If you can do the math, you're set to go. All right? The last couple of things you might need to know are different types or specific types of equations that don't have the 2 variables. Right now you have 2 variables. That's in slope-intercept form. You'll learn about that in a little bit. We had the other one in standard form. We have another couple of graphs we can look at, but I want to move on and show you 2 last graphs that you're going to see from time to time. I'm going to just put up some blank coordinate grids, and I'm going to put a line up here. And I'm going to say that this is y equals, what's this? 1, 2, 3, 4. Y equals 4. You see that there's no extra variable, right? It just says y equals 4. And what that means is, it doesn't matter what you put in for x. What you're going to always get out is 4. So there's no real math work that needs to be done. Y equals 4 is just the graph of a horizontal line. All right? And then the last one, obviously, is a vertical line. And when you learn about functions, and you will, we'll call this one x equals -3. You're going to learn something cool. Sorry, I'll write vertical up here. You're going to learn something cool. You're going to learn something called the vertical line test. And you'll see if this function, if this equation, this graph here represents a function. And linear functions, those straight lines, the things that we've been looking at, are actually functions, right? You put in something and you get out a specific output. You have an input with a specific output. So you do the vertical line test. Anywhere you cut through it with a vertical line, it only touches this one time. So a horizontal line is a function. It means it has a slope. This one actually has no slope, but the input gets out its own specific output. Here, this is not a function. This is not a function because it's a vertical line and its slope is undefined. And you're going to learn about slope in about 3 or 4 sections as well. But this is not a function. It exists and you can graph it, but there's nothing cool that we can do with this other than say, ding, x is -3. We have a vertical line. We don't have to do any inputs or outputs. Everything is just x equals 3. Right? We don't care what the output is. X equals -3. That's it. So those are the things that you're going to be looking at in this section. Again, if you have any questions, please tell your dad. Your dad will tell me, and this crazy old guy will try and get an answer to you as soon as possible.